Next part is I will explain the instrumentation of methods of analysis, which are the modern techniques used to measure metals and minerals with high accuracy, sensitivity, and speed compared to the classical method. The first is the spectrophotometry. Light source, sample, and to the detector. Measured how much ultraviolet or visible light is absorbed by a solution. Spectrophotometry. Light source to the sample to the detector. Measured how much ultraviolet or visible light is absorbed by a solution. This is often used when metals are converted into polar complexes and absorbance is compared to a standard curve to determine concentration. The principle of spectrometry is based on the measurement of the light absorbed by a solution. When a light is a specific movement passed through a colored solution, part of it absorbed by the analyte. The more concentrated the solution, the greater the light absorbed. This method follows Beer-Slumberg's law, which states that absorbance is directly proportional to the concentration of the analyte and the path and length of light through the solution. Steps in spectrophotometric analysis. First is prepare or sample or solution. Add reagent to the conform color complex if it's necessary. Place sample in cuvette. Select a suitable wavelength. Measured absorbance with a spectrometer. And then lastly, compare the absorbance to the standard calibration curve. You have here the examples. Iron, the phenolphthalein method, which is orange to red complex. Here is the image. Coppered ammonia solution, deep blue complex, from lighter to deep blue. We have nickel, the dimethylglucosamine complex. This red to pink. The concentration of a metal is calculated by plotting a calibration curve of absorbance against the standard concentration. The absorbance of a known sample is then matched to this curve to determine its concentration. In summary, spectrophotometry is a sensitive and accurate method that measures the absorbance of light to determine the concentration of metals in solution. It is widely used in metallurgy, mining, and environmental analysis.
Next is the X-ray diffraction or the XRD and the X-ray fluorescence or the XRF. These both X-ray, but for different purposes in minerals and metal analysis. Now, first is the X-ray diffraction or the XRD. The principle of XRD is based on Bragg's law. When X-rays strike a crystalline material, they are diffracted at specific angles. By measuring these diffraction patterns, we can identify the crystal structure of a mineral. Steps in XRD analysis. First is the ore sample is finely powdered and exposed to X-rays. The resulting diffraction pattern is recorded then, showing a peaks at characteristic angles. These peaks are compared with a reference database based to identify the mineral composition. Icons and the examples. We have minerals identification such as quartz, feldspar, and hematite, determining the crystal structure and the lattice spacing, and the studying clay minerals in soils. Now is the X-ray fluorescence or the XRF. The sample is bombarded with X-ray, which cause atoms to emit secondary X-ray. Each element emits a radiation at a unique energies, allowing us to identify and quantify metals in ore quickly without dissolving the sample. The principle of XRF is based on the X-ray excitation. When a material is exposed to a primary X-ray, its atoms emit secondary or fluorescent X-ray. Each element has unique energy levels, so the emit X-ray levels both the type and amount of elements in the sample. Now, here is the steps in XRF. First is to prepare or prepare the solid or the powdered sample, then expose the sample to the primary X-ray, and then detect the fluorescent X-ray emitted. And lastly is to analyze a spectrum and identify and quantify its elements. XRF is widely applied in determining ore grades such as copper, zinc, and iron. It is also used in environmental testing of heavy metals and in industries such as cement, production, ceramics, and metallurgy. So here we can see the comparison table of X-ray diffraction and X-ray fluorescence. So XRD identifies minerals and crystal structure, and its output is diffraction pattern. The XRF is identifies the and quantifies any minerals, elements, perhaps, rather, I mean, elements composition. So in summary, XRD and XRF are complementary techniques. XRD is used to minerals and crystal structure, while XRF is used to determine the elemental composition of an ore or a materials. Next is the microanalysis, a method used to determine the composition of a very small amount of material, often at the microscopic or even atomic level. So microanalysis. Microanalysis is refers to the detailed examination and identification of extremely small samples of material, whether in terms of sample size, well micrograms or microliters, the tiny volume of material analyzed, or the analysis of individual microscopic features within a larger object. The principle of microanalysis is study materials of microscale use a high energy beam, such as electrons, to generate signals from the sample. This signal reveals the elemental composition, structure, and morphology of a material. So there are types of microanalysis. Sometimes some types includes electron probe microanalysis, which or EPMA, which use an electron beams to analyze small spots of a sample. Then the scanning electron microscopy with EDS that can study a surface composition and transmission electron microscopy, or the TEM. It is used to examine internal structure at the atomic level. So we have the steps. First is to prepare a very small or a polished or a thin sample. Next is to expose sample to electron beam. Then collect that example emitted signals, the X-ray or the electrons, and analyze spectra to identify its element. And now you can generate images or maps of elemental distribution of the sample. So we have the application of microanalysis. Microanalysis has many applications. In mining and metallurgy, it is used to identify trace elements and maps elemental distribution in ores. In material science, it helps with failure analysis and studying defects in crystal or metals. It is a high precision, a small scale samples and it identifies trace metals. So again, the instrumental method analysis are the spectrometry, the the X-ray diffraction or the XRD, and XRF or the X-ray fluorescence. Then lastly is the microanalysis. That would be all, sir. Thank you, and God bless.